Dear students, the next question from work power energy NEET based question number 21. A ladder AB of weight 300 Newton and a length 5 meter is lying on horizontal surface. Its center of gravity is at the distance of 2 meter from end A. A weight of 80 Newton is attached at the end B. The work done in raising the ladder to the vertical position with end A in contact with the ground is. So some option is given: 500 joule, 1000 joule, 1150 joule, 1900 joule. Like that some option is given. Let's discuss this concept as well as the solution. Listen students. So I'll read the question. A ladder AB of weight 300 Newton and length 5 meter is lying on horizontal surface. Okay, so let's imagine it is that ladder. Okay, the ladder. Okay, so here two end. This is end A, this one end B. The total length of this ladder is 5 meter, and then the total weight of this ladder is 300 Newton. 300 Newton, that is the weight of the ladder. Then the length of the ladder is 5 meter. And then when 80 Newton is attached with NB. So with the NB I can attach 80 Newton weight. So center of gravity of the ladder AB is changing from its center to 2 meter distance from A. Okay, this is 2 meter distance. 2 meter distance from A. This is the center of gravity. Center of gravity. Simply I write here CG. Center of gravity of this ladder 2 meter from A. Okay. So this is given information. Now this ladder to turn vertical position. So after turn this vertical position, so here the center of gravity, here is the center of gravity, then this 80 Newton weight is here in the top. 80 Newton weight is in the top at the end of B. Now the A end is at the surface. Okay, so from horizontal position to vertical position we changed. So for that, how much work done we did? So that work done only we are going to calculate. So it is purely vertical position, so it is depends upon potential energy. So that total work done is equal to, okay, the potential energy of the potential due to that entire ladder plus the potential energy of this additional mass. Okay, so we want to the potential energy of this ladder plus the potential energy due to this mass, this additional mass. Okay, so now we can write work done is equal to, generally the potential energy of ladder, that is mgh, then potential energy of this mass, that is also mgh. Now let's say write this is taken as m, so m into g, because Newton is a force, it's a weight, so m into g. Okay, so and then the mass of the or otherwise yes, the mass of the ladder, that is m dash, then into g, it is known as, that is the weight of the ladder. So m dash g is represent the weight of the ladder, mg is represent the weight of that additional mass. Okay, right. So now we can substitute the value here. So m dash g, that is 300 Newton, so 300 Newton, and then height. So let's we see that this is like a uniform body. Okay, so because we consider only the ladder here, the potential energy due to the ladder. Okay, so here the entire mass is concentrated at its center of gravity. So that center of gravity, that is 2 meter from A, so that 2 meter will come here. Okay, then plus then mass into gravity, that is mg, it is represent that mass, that is 80 Newton, and then the height, the total height, from the ground, its total height, that is 5 meter, so the 5 will come here. Okay, so here first part I consider that entire body of the ladder, so let's say taken as its center of gravity, the height is considered as a center of gravity, but this is the mass alone, it's not entire body, this is a mass alone. So now the mass is at a particular height, so the height is depends upon the potential energy. So here the total height is a 5 meter height, so I can write 5 here, h value is high. Okay, for understanding purpose, so I can write this is h dash. Okay, this h is 5 meter, so now we can write work done is equal to, so this is 600 plus this one 400, so the work done is equal to 1000 joule. So we require 1000 joule work. If you apply the 1000 joule work, this ladder will move from horizontal position to the vertical position along with the mass of 80 Newton on the top of the ladder. Okay students, I hope you understood this question. So this answer is matched with the option is B. Okay, thank you.